Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. 4 boys and 3 girls are to be seated in a row of 7 chairs. What is the probability that all the boys are seated together? So altogether 4 boys are there and 3 girls are there. So what is the probability that all the boys are seated together? So first we'll find out the total number of outcomes. Altogether 4 plus 3, 7 people are there. They are all different and they can be interchanged among themselves in 7 factorial ways. So this is the total number of outcomes. Now we look at the favorable outcomes where all the boys are seated together. They are together means bring them together and treat it as one person. Then the 4 boys will always be together. So if you treat it as one, now effectively 4 people will be there. These 3 girls and this one person also. So 3 plus 1, altogether 4 of them can be interchanged in 4 factorial ways. And in each of these 4 factorial arrangements, the 4 boys among themselves, they can be interchanged. 4 boys among themselves in 4 factorial ways, and the boys will always be together. So this is a total number of favorable cases out of a total of 7 factorial. I'll cancel out 4 factorial here. So remaining will be 7 into 6 into 5. 4 factorial is 4 into 3 into 2. 3 into 2 is 6. I'll cancel with the 6. So remaining 4 is there out of 7 into 5, 35. So the required probability is 4 out of 35, option B. A coin is tossed 6 times. Find the probability of getting exactly 4 tails. So one favorable outcome is the first 4 are tails and the next 2 are heads. So let us calculate the probability of this. First one is a tail, that is 1 by 2. Next one is a tail, 1 by 2. Next one is a tail, 1 by 2, like that 6 times. So the probability will be 1 by 2 raised to 6. These 4 tails and these 2 heads, they can be interchanged in any way you like and it will be a favorable outcome. So in how many ways can they be interchanged? And in each arrangement, the probability will be 1 by 2 raised to 6. So we can use the formula n factorial by k1 factorial into k2 factorial. Here altogether 4 t's are there and 2 h's are there. So n is equal to 4 plus 2, 6 of them. Out of which 4 of them are same, 2 of them are same. This is a total number of arrangements. 4 factorial I'll cancel with 6 factorial. So remaining 6 into 5. 2 I'll cancel here. So 3 into 5, 15. 15 out of 2 raised to 6. That is 15 out of 2 raised to 6 is 64. So the required probability is 15 by 64, option D. A coin is tossed 9 times. Find the probability of getting exactly 6 heads. So one favorable outcome is initially you get the first 6 heads and then you get 3 tails. So altogether 9 tosses of a coin. So this is one favorable case. So let us calculate the probability of this. First one is a head, that is 1 by 2. Second one is a head, that is 1 by 2. Next one is a head, that is 1 by 2. And for each it will be 1 by 2. So this and this and this and this 9 times. So you have to multiply. So you will get it as 1 by 2 raised to 9. Now these 6 heads and these 3 t's you can arrange in any way you like. And the probability is always 1 by 2 raised to 9. So in how many ways can they be arranged? That is, we can use the formula n factorial by k1 factorial into k2 factorial. That is, n objects are there, out of which k1 of them are same, k2 of them are same. All the n are taken out and arranged in order. How many arrangements are there? Directly substitute into this formula. Here 6 heads are there. So 6 heads and 3 tails. So n is equal to 6 plus 3, 9. So n factorial by k1 factorial into k2 factorial. 6 of them are same and another 3 of them are same. Now 6 factorial I will cancel with the 9 factorial. So remaining you have 9 into 8 into 7. And 3 factorial is 3 into 2. 3 I will cancel with 9 3 times and 2 4 times. So this you will get it as 3 into 4 into 7. So 3 into 4 into 7. This is the total number of arrangements, and in each arrangement the probability will be 1 by 2 raised to 9 into 1 by 2 raised to 9. Now this is 2 square. I'll cancel with this 2 raised to 9 and it will be remaining 2 raised to 7. So what we have is 3 into 7 is 21 out of 2 raised to 7. That is 21 out of 2 raised to 7 is 128. So 21 out of 128. That is option A. A coin is tossed 5 times. Find the probability of getting exactly 3 tails. So exactly 3 tails means one favorable outcome is the first 3 of them are tails, and then you can get head and head. So this is one favorable outcome when you get exactly 3 tails. So let us calculate the probability of this. First one as a tail is 1 by 2. Second one as a tail is 1 by 2. Third one as a tail is 1 by 2. Then the next one as a head is 1 by 2, and the next one as a head is 1 by 2. So that you will get it as 1 by 2 raised to 5. Now let us look at another favorable outcome. Another favorable outcome is first 2 of them are heads, then you get 3 tails. Now let us calculate the probability of this. That is, first one as a head is 1 by 2, second one as a head is 1 by 2, next is a tail is 1 by 2, next one as a tail is 1 by 2, and next one as a tail is 1 by 2. So again 1 by 2 raised to 5. So these 2 heads and these 3 tails can be interchanged among themselves in any way you like, and the probability is always equal to 1 by 2 raised to 5. So we'll find out in how many ways they can be arranged. That is, here 2 heads are there and 3 tails are there. In how many ways can they be arranged? You can use a formula n factorial by k1 factorial into k2 factorial. That is, n objects are there. K1 of them are same, K2 of them are same. All the n are taken out and arranged in order. How many arrangements are there? Directly substitute into this formula. So here 3 plus 2, 5 objects are there. So n is equal to 5, out of which 2 of them are same, 3 of them are same. So 5 factorial by 2 factorial into 3 factorial, that is, you will get it as 10. So 10 possible arrangements are there of 3 tails and 2 heads. And in each the probability will be 1 by 2 raised to 5. 10 is 2 into 5. 2 I'll cancel with the 2 raised to 5, remaining 2 raised to 4. So the final answer will be 5 by 2 raised to 4. That is same as 5 by 16. So the required probability is 5 by 16. That is option A. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests. And these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only rupees 200. So all that you need to do is make a payment of rupees 200 either through Google Pay or through PhonePe or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.